Alright, now that we know how to calculate some solutions' molarities and concentrations, we can actually make our own solutions. From this point on, I can ask anyone to make any solution at any time, which is always great for me because then you can help me set up labs. To make a solution, you want to use a volumetric flask. It is essentially one purpose in its life, and that is to measure an exact volume of a solution. For instance, a 500 milliliter volumetric flask has a little, it's basically a very long-necked little flask like this, and has a little round bottom. And here's its top, and then it has a line that is the fill line. And when you make your solution, if you fill it exactly to that line, then that should be the exact volume that you need. When you create a solution, what you want to do is you add a little bit of water to the flask, then you measure out the amount of your solid that you need to put in, and then you get it to dissolve, and then you add the rest of the water up to the line. Okay, so if our experiment requires 500 milliliters of a 0.02 molar solution of potassium permanganate, if I give you a bottle of solid potassium permanganate, some distilled water, and a 500 milliliter volumetric flask, describe how you would go about making up the required solution. So the key parts that we need here are that we need 500 milliliters, and that it needs to be a 0.02 molar solution. I'm going to sort of work my way backwards because we have to figure out how many grams of potassium permanganate we're actually going to need. Alright, so I'm going to start off with my concentration, 0.0200 moles per liter. At that point, I'm going to try to figure out the mass because I know the volume that I'm contending with here. So I'm going to go ahead and get rid of the volume by multiplying it by the volume we're going to use. So liters, I need 500 milliliters, which is half of a liter. You can put that over 1 if you want, or you can just recognize it. The next thing that I need to do is I need to get the molar mass. So 1 mole of potassium permanganate. K is 39.1. Mn is 54.94. And oxygen, of course, is 4 times 16. So when I add all those up, I get 158.04 grams per mole, and I can use that in this equation, or this calculation, I should say, and then I can take a look at what I've got. I have liters canceling, I have moles canceling, which will leave me with the number of grams that I need. And that is 1.5804 grams. So this actually could even be a pretty decent one that they might give you on the AP test, because the 2 and the 5 multiply to give you some version of 10. So 0.02 times 0.5 would give you 0.10, and so you have to move the, or 0.01, and you have to move the decimal over, or you can use a calculator, either way. So at this point, the way that I would do this is I would maybe add about 100 milliliters of water, distilled water, to the flask. Then I would add 1.58 grams of potassium permanganate and shake. Next, I would add distilled water to the fill line. Okay, you are now officially able to make solutions. The next topic that we're going to hit is dilution of something that is already in its aqueous form. The target is describe how to prepare a solution of given molarity by dilution of a more concentrated solution of known molarity. And a lot of times what happens is maybe you'll have something that is very concentrated, like 6 molar copper chloride or something like that, but you only need 0.1 molar. So rather than getting the solid out and making something new, you can just dilute what you already have. This is also really, really important in dealing with acids because they all come in the liquid form as it is. For instance, sulfuric acid is 18 molar H2SO4. Hydrochloric acid comes as 12 molar HCl. So they have to be diluted. There's not a solid that you can work with those. The equation's pretty cool. It's M1V1 equals M2V2. So it's the molarity initial times the volume of that initial stuff that you have to use, and that you set that equivalent to the final molarity and the final volume. So in exercise 16, we have an experiment that calls for you to use 300 milliliters of 1.0 molar sodium hydroxide. So this is the final volume that we need to use and the final molarity. But you are given a large bottle of 3 molar NaOH. So that's your initial molarity. Tell how you would make up the 1 molar sodium hydroxide in the desired volume. So the first thing that we need to do is calculate how much of the sodium hydroxide, the original concentration, we need. So let's use our equation. We have M1V1 equals M2V2. Let's plug in the variables that we know. We know we have 3.0 molar sodium hydroxide. We're trying to find out how much of that we need to make 1.0 molar sodium hydroxide and 300 milliliters of it. In this case, you can use either milliliters or liters. Just make sure that you actually convert appropriately, and as long as your units match, then you're okay. So at this time, you just solve for V. So 1 times 300 and then divided by 3. So that tells me that I need a volume of 100, and I was using milliliters here, so 100 milliliters. In order to actually make this solution, I'm going to use a volumetric flask again. And I will probably add, no matter what you do, it's usually better to add the water first. So add about 150 milliliters of distilled water to the flask. Then I would add 100 milliliters of the 3 molar NaOH, and I would do that with the graduated cylinder. And then, oops, this is only step 3, and then I would fill to the line with distilled water. So that is how you make them.